sign of this partial is, what we assumed before is that larger stock make your marginal cost lower. So yeah, well, if dc ds is negative, then implicitly this is going to add a negative quantity. Yeah, so the math is correct. You're right. We need to be careful. We need to remember that the dc dy. So increasing y is going to probably increase marginal costs, but increasing s is going to decrease them. We need to bear that in mind. Okay. All right. So I'm going to draw you a picture to go with this expression. Let me do it. I want to kind of keep that thing around. Leave this here. No, not here. Here. Okay. So this is our key expression. I'm going to go back over here. And notice that I can, first of all, simplify this quite simply. I've got I've got t 1 over 1 plus r's here. I've got t plus 1 of them here. So I can divide, or I can multiply through by 1 plus r to the t and get a simpler expression. So this all implies that we have pt minus, or I'll do it this way, equal to dc t dyt, and then minus dc t plus 1 dst. Actually, this should be st. Oh, this was called ds. It's the positional argument. Yes. Yes, it's all coming. It's the chain rule, as we said before. So here's the maximization problem. So yt shows up, here in period t, and shows up in this position, which is like what I'm calling the s position. Shows up in the stock in the subsequent period. So then using the chain rule, I get a dc ds times minus 1, and that's just the chain rule, as I said. Okay. I'm worried about this sign here now. So the slide has an error. I think I was correct on the board. The slide here has an error because this should be negative. Okay, so yes, so fix that. And that's related to the issue that you brought up. Okay. All right, so anyway, so we've got this thing as our first order condition. Notice the 1 over 1 plus r term here. Okay, so now let me draw you a picture to go with this. Here's the picture. Let me do it. I can fit it here, I guess. No, I should make it bigger. Let me put this on. Erase it all. Yeah. I want to keep that expression. Okay, so I got that. Now ask yourselves a question while I draw this. How does this compare? How do these first order conditions here compare with the first order conditions we had in the static case? Do you recall? In the static case, where the firm was just solving this problem in one period that we analyzed last week, do you recall what the first order conditions look like there? Yeah, actually, we had everything was the same except this term was missing. So in particular, and you guys correctly complained about this, said, well, the firm is going to choose its output to equate its marginal revenue, which is its price, with its marginal cost. But in the old analysis, it didn't take into account the fact that extracting more today would increase its future costs. So that was a defect in our previous analysis that we fix now. So now the firm is going to take into account the current marginal cost it has, plus the fact that its extraction today is going to make it more expensive to extract in the future. Okay, so here's the new picture I want to draw. I'll have PT up here. I'll have current extraction on this axis. So we're back in the world of sort of Marshallian supply. Let's let this curve be dCt dy. So this is the marginal cost the firm has. If the level of price is this, say, in the old analysis, the firm would have chosen to extract this much in the static case. But now it's not going to do that. Now what it's going to do is also take into account this piece. And so there's some effect of extracting yt on this thing. This is a function of yt. It might look like this, say. So this is going to be minus dct plus 1 ds, all as a function of today's extraction. And so what this takes up is the fact that if you extract more today, you're going to increase your marginal costs tomorrow. Okay, and the minus is here because more stocks is good for you, less stocks is bad. Yes? Yeah. We're going to be, I may run out of time, but I'm going to talk about that either in the next few minutes or else on Tuesday. So yeah, I have a t subscript on this thing because I want to consider the possibility that prices will change. So right now though, you're going to care about current prices. And even if you know the prices are going to increase in the future here, we've already got the way we formulated the problem allowed for prices changing. So the fact that prices are going to go up in future periods isn't going to affect your decision to extract here. Okay. So this is minus delta CTDS times this other factor though, which is 1 over 1 plus r that we need to take into account here. And the total marginal cost that the firm takes into account when it's going to do its calculation about how much to extract today is going to depend on the current impact on marginal costs, the future impact on marginal costs, but it's going to discount the future increasing cost by the interest rate. Yes. The negative sign is probably showing up here just because I've got this piece. It's that this is dCt plus 1 ds. So if stocks increase, that lowers your marginal cost, but the effect of yt on this thing is negative. Yeah. So this is again just going to change. I'm just writing down the different terms on the right-hand side of this equation. So what the firm cares about for its supply decision is the sum of these two curves. So let me see if I can sum those. Take this to this. I wind up with something like this, perhaps, as the sum of these two expressions. So this is the whole right-hand side of this. This is dCt dy t minus dCt plus 1 ds, all times 1 over 1 plus r. And so this is the point now where this firm is going to use to decide about how much to extract today. All right, so now, we're not quite going to get to the question of changes in prices, but what happens if interest rates go up? If we change r, what happens to this expression? Suppose that r goes up. Well, r goes up. This means that this term gets smaller. But this thing is, but remember, the costs go down with supply, so this is a negative quantity. So as you say, this negative thing gets smaller. So if r goes up, we'll get something smaller here. We'll just rotate the whole thing down. And as a consequence, we'll get a decrease in the sum. So the effect of an increase in interest rates is to move out the marginal cost curve and increase current extraction. Yes? Yeah, that's so I'm holding interest rates fixed fixed here. So we're not doing the thing where interest rates can vary over time right now, although the analysis doesn't change very much if you do. Right now, this is like a once and forever kind of change in interest rates. What we're changing is the trade-off that the firm is willing to make between income today and income tomorrow, because rather than getting out YT or PT times YT revenue today at some cost, it could instead take the turn around and invest that quantity in a bond, and if interest rates are high, it'll receive a larger payment for that. So extract more today because you can invest. The returns to investment are high today. And in general, you can see from this sort of analysis, and this is true for any natural resource problem, the rate at which you want to extract stuff is going to depend on the interest rate. The interest rate is key. I mean, we sort of spent the last couple of lectures talking about bonds and finance, and it may have seemed remote from natural resource problems, but the rate at which you want to extract resources over time depends critically on what interest rates are. Okay. All right, I'm going to stop there. So we'll return to exactly this topic next Tuesday. Have a good weekend.